Okay, we've defined this crazy thing called the convolution of functions. It does have a connection to Laplace transforms. So if the Laplace transform of little f is capital F of s, and the Laplace transform of little g is capital G of s, this thing that we call the convolution, which we denote with this asterisk or this star, so it's f star g, this is the inverse Laplace transform of the product f of s times g of s. So it's the inverse Laplace transform of a product of Laplace transforms. And it's defined as this sort of wonky integral. We integrate from 0 to t. Now it's a product, f times g, that we're integrating, but f is evaluated at t minus u, and g is evaluated at u. Okay, I understand you would like to know why we care. You would like to know if you should care, perhaps, okay? But is this possibly useful, or is this just this wonky definition that's out there? I get that you want to know that, and I promise we are going to take a look at why this might actually be useful, okay? But I think we're going to be better equipped to address that question if we just get more comfortable with the mechanics of how this actually works. So in this video and the next, I just want to practice calculating some convolutions. Once we feel a little more comfortable with that, we will, I promise, come back and take a look at why are we doing this, other than, well, it was in the book. Okay. All right. So I've said let's let f of t be e to the negative 2t, just a nice exponential function. We'll let g of t be our heaviside function at 3. Okay. So if I want to calculate f star g, that's going to be the integral from 0 to t of f was my exponential function, so that's e to the negative 2 times t minus u. G was the heaviside function, so that's mu sub 3, just writing u as my variable for that, and we're integrating that du. Okay. Now, in order to evaluate that, I'm really going to need to know whether t is bigger than 3 or not. Okay. So I'm going to have to sort of define this, at least initially, piecewise. I'm just going to get 0 if t is less than 3, because 3 is where I'm turning this on. Okay. So if we're less than 3, the heaviside function is just 0. This is completely turned off. So if I integrate from 0 to t, and t is anywhere to the left of 3, I'm just integrating 0. But if t is bigger than or equal to 3, then there's going to be some portion of this interval where my function is turned on, so I have something non-zero to integrate. So I can say this would be the integral from 0 to 3 of 0 du, because it's turned off until then, plus the integral from 3 to t. Now this is going to be turned on at 1, so I'm just getting this, which I can rewrite as e to the negative 2t times e to the 2u du. All right. Now I'm integrating with respect to u. There are no u's in that. That is constant. I can pull it outside of the integral. So I'm going to have e to the negative 2t times the integral from 3 to t. That's my upper limit of integration, which I'll eventually be plugging in for some u's once I take an antiderivative. But that t is the same as that t. It was a constant. I can pull it out. Okay. So then we've just got e to the 2u du. So a quick w sub. Let's let w be 2u. So dw is 2 du. So we'll introduce a 2 counterbalanced with a 1/2. So I'm going to get e to the negative 2t over 2 times the integral. From the w value at 3 will be 6. To the w value at t will be 2t. And then it's just e to the w dw. So that is e to the negative 2t over 2 times e to the w evaluated between 2t and 6. So that's e to the negative 2t over 2 times e to the 2t minus e to the 6. So let's see if we can't simplify that. I think I'm going to just distribute this on through. Notice that e to the negative 2t times e to the 2t is just e to the 0, which becomes 1. I'm going to come up here to write that. Minus e to the negative 2t times e to the 6 is going to be e to the negative 2t plus 6. And this is all over 2. Okay. So that's what I get here if 1 minus e to the negative 2t plus 6 all over 2 if t is bigger than or equal to 3. Now, if I want, I can actually write this a little bit differently. I can say this is 0 if t is less than 3, and 1 minus e to the negative 2 times t minus 3 all over 2 if t is bigger than or equal to 3. Don't need to do that, but I certainly can. But I do think I want to try to write this not as a piecewise function, and I can do that by just using the Heaviside function. So I can say f star g is going to be the Heaviside function at 3. Now this is a function of t now, so it's the Heaviside function evaluated at t. That turns things on at 3, and what it turns on is this function. So 1 minus e to the negative 2 times t minus 3 all over 2. That is my first lovely convolution. Excellent. Okay.